This is the continuation of question 26 in the Technology Masterclass for Mathematical Methods, Part C. What values of m and n will make g and its inverse equal to each other, where I have a general rule. I found out in Part A and B that this gave me identically the same function as its inverse. So I put the x plus m over x plus n and I turned it into a proper fraction and I had a plus 1. So the inverse will have an asymptote at y equals 1. So y equals 1. Therefore, the original must have an asymptote at x equals 1. Therefore, n must equal -1. So that's a given. But what can m equal? It obviously can equal -4, because up here in this example here, that gave me the inverse and its function being the same. But can m equal anything? Let's just check and see. So I know that n has to be -1, so I'm going to make that -1. And if I copy it, and I go over into graphs and tables, and I paste, and in terms of m, so I'm going to look at this one here. So when m equals -5, -4, -3, -2, -1, m can't equal -1, because that gives me a horizontal line and its inverse would be a vertical line. But it can be 0, can be 1, 2, 3, 4, 5, 6, 7. So m can be anything except -1. And of course, when I've got x minus 1 over x minus 1, that cancels to give you a 1, which means y equals 1. Okay, so n equals -1, and m is an element of everything except -1. That's what part C is.